Welcome to our tutorial on setting up an IPsec Auto Discovery VPN with two ISPs, using BGP as the overlay routing protocol. As you can see on the diagram, there are 3 sites, HQ and 2 branch offices. The Auto Discovery VPN uses hub and spoke network topology, thus we will configure HQ as the Auto Discovery VPN hub and the 2 branches as spokes. The advantage of using Auto Discovery VPN is to ensure that spoke-to-spoke traffic does not always traverse the hub. Dynamic VPN tunnels are created on demand between spokes. Prefixes across sites will be learned via BGP. Also, we will be using SD-WAN to choose the best link in terms of latency over the 2 ISP connections at each location. I will be providing explanation to the configurations as we move along, so let's begin. I have already verified network connectivity between hub and spokes. We will start with the configuration on the hub. Create a new SD-WAN zone, which will be used specifically for IPsec tunnels. Then create SD-WAN members for this zone. Instead of creating the IPsec VPN tunnels and adding them as zone members, we can easily create them from here. Enter the name of the VPN via ISP1 and enter the remote gateway IP. For now, use any dummy IP as gateway IP since it will soon be removed. Enter the pre-shared key. Add the second VPN via ISP2 also as zone member. Now let's customize our 2 IPsec VPN tunnels. For remote gateway, choose dial-up user. This will allow the hub to form IPsec tunnels with multiple spokes. Disable add route. This ensures that IKE does not automatically add a route when the dynamic tunnel is negotiated. Routing will be accomplished via BGP. Enable Auto Discovery Sender. With this setting, when IPsec traffic transits the hub, it will send a shortcut offer to the spoke that initiated the traffic to indicate that it could perhaps establish a more direct connection. Set the other Phase 1 and Phase 2 parameters according to your requirements. I will leave them at their defaults. The Phase 2 local and remote addresses on the hub should be set to all. We are done with the IPsec tunnel configuration on the hub. Firewall policies are next. 2 firewall policies are needed. One policy to allow spoke-to-hub traffic, and another to allow spoke-to-spoke traffic. In the spoke-to-hub rule, choose all for the source address and disable NAT. But in the spoke-to-spoke rule, the source and destination interfaces should be the SD-WAN zone we created, and select all for the source and destination addresses. Again, disable NAT. Let's assign an IP address to the 2 tunnel interfaces. This will be used by the overlay routing protocol. The remote IP should be an unused IP address in the overlay subnet. For ISP1, the overlay subnet is 10.100.100.0/24, and the overlay subnet for ISP2 is 10.200.200.0/24. For routing, we will configure two separate IBGP between the hub and spokes, and the hub will be configured as a route reflector, one IBGP for each overlay network. Then advertise the LAN network of 10.0.0.0/24 to the spokes via BGP. Let's turn our attention to the spokes. We will return to the hub again. On spoke 1, create an SD-WAN zone and add two member tunnel interfaces. In customizing the VPN tunnels, disable Add Route and enable Auto Discovery Receiver. With this setting, the spoke indicates that it wishes to participate in an Auto Discovery VPN or wants to receive a shortcut offer. Set the other Phase 1 and Phase 2 parameters to match those on the hub. You may enable Auto Negotiate. Create two firewall rules on the spoke, one for inbound and the other for outbound. For inbound traffic, choose all for the source address. Then for outbound traffic, select all for the destination address. Disable NAT in all firewall policies. Let's assign IP addresses to the two tunnel interfaces. I will quickly repeat the same thing also on spoke 2. For routing, we will configure two separate IBGP between the hub and spokes, an IBGP for each overlay network. The remote AS number should be the same as that on the hub, and the BGP neighbor IPs should be the tunnel IP addresses on the hub. Then advertise the LAN networks via BGP. I will set the BGP route's advertisement interval to 1 second on the spokes. Next is SD-WAN, but before, let's check the state of the auto discovery VPNs and BGP neighborship on the hub. Everything looks good so far. We will begin the SD-WAN configuration by creating two performance SLAs to check network connectivity to the local area networks of the spokes over IPsec VPN tunnels using the ping protocol. It is imperative that these ping SLAs are sourced from an IP address in the LAN subnet of the hub. This source IP can only be configured in CLI. Next, let's configure two SD-WAN rules, one for each spoke. Make sure the selected measured SLA matches the right spoke. We will repeat the same thing on the two spokes too. Pay close attention to the server IPs used for the performance SLAs on the spokes. Again, pay attention to the source and destination addresses used in the SD-WAN rules on the spokes. Now we are done, but do you see that only one performance SLA is working? Do you know why? Well, it is because equal cost multipath routing is not enabled for SD-WAN and BGP, so let's enable ECMP on all nodes. For SD-WAN load balancing algorithm, we will change if from the default value of source IP-based to weighted-based. By default, FortiGate supports a maximum of 255 equal-cost multipath routes. I want to change it to only 4, at least for the sake of demonstration. Then finally, let's enable equal-cost multipath for IBGP. We should now find both performance SLAs at each location working. Hence, the hub or the spokes can check the quality of the two ISPs, in our case, check the latency, and pass traffic based on which ISP route has lesser latency. Since the SD-WAN performance SLA pings are up, it means there is end-to-end connectivity over the VPNs. Because of the auto-discovery VPN configuration on the hub and spokes, traffic between spokes will not traverse the hub. Great, we have created IPsec auto-discovery VPNs between 3 locations with SD-WAN, where each location had dual ISPs. Thanks for watching our tutorial. If you have any questions or need further assistance, please feel free to leave a comment below. Don't forget to subscribe to our channel for more helpful tutorials. See you next time.